So on your exam, if you are a CCP student, you cannot write the unit circle on that note card that I give you. So you can write whatever else you want, but you can't write the unit circle. The problems or the formulas up on the board will be provided, so don't waste your time writing those down unless you want to write like an example down if that helps your brain. We are going to be looking at this final exam review each day. As we do it each day, it is your responsibility to turn in that day's work. Remember, for seniors, your last grades for the 9 weeks include the Chapter 10 stuff we did last week and the 4 grades for each day's work we do this week. And then your final exam, and then you're done for grades, okay? All late work is due by Friday for my seniors, so please make sure to get those things turned in if you're missing anything. Okay, so as we do these, when we're done at the end of the period, please go ahead and turn in what you have done so far at that particular time. We're going to mostly be focusing on the ones that I've circled. We're not going to probably do this entire packet, so don't expect that to be a thing. Okay, let's start with 1A. If we convert each angle to decimal degree form, remember that every degree has 60 seconds in it and 3,600 or 60 minutes in it and 3,600 seconds. So this is going to be 75. We have 54 out of 60. We have 30 out of 3,600. So you're just going to enter that, use division. So it's going to be 75 plus 54 divided by 60 plus 30 divided by 3,600. Now, you're going to round like they said. You're going to round your answer to the thousandth place, so 3 decimal places. So it's 75.908 degrees. Okay? We're not going to do B. Please look at A. We're going to change it up a little bit. Could you make that 3.575 degrees? Okay, just so we have a little more to work with. So it says convert each angle measure to degrees, minutes, and seconds. So what we know right now is we have 3 full degrees. So we take that off. So any whole number you're going to take off. You're going to put the decimal in the calculator, and you're going to multiply the decimal value only by 60. So it's the exact opposite. Instead of dividing by 60 like we did in number 1, we're going to multiply by 60. We're going to get 34.5. We're going to take that off, and that is our next thing. That is our minutes. And then any decimal that's left again, we multiply by 60 again, and that is our seconds. So we have here 3 degrees, 34 minutes, and 30 seconds. So for number 1, we divide by 60, and then we divide by 60 again, which is 3,600. And that's where we get that. For number 2, we do the opposite. Take off the whole number, multiply the decimal by 60. Take off the whole number, multiply the decimal by 60. So that is something hopefully that's very easy for you. Number 3. The key for number 3 is to remember that 180 degrees is a pi worth of radians. If you just know that number 4 is what it is from the unit circle, feel free to just write it down. But you can always do, take off the pi, replace it with 180. So 4 times 180 divided by 3 is 240 degrees. So if we did the same thing for number 6, that is 150 degrees. So you should know how to do that. Take off the pi, replace it with 180. There you go. They did not have going the opposite way, so let me do that for you. Let's add a little C here. Let's say we want to go from radians, from degrees to radians. And let's say we have 100 degrees. for that, remember, we tack on a pi, we put it over 180, and we reduce it as much as we can, leaving your pi in your answer. Both of those are divisible by 20, so you would get 5 pi over 9. Do we have any questions 1, 2, or 3? Have any questions for those? Okay, for 4, the formula we need is right over here, that the arc length is radius times radians. So it's just your angle measure times your radius. But you have to have it in radian measure for this formula to work. So let's look at 4a, because 4b is the easy one. You just multiply 3 times 1. But 4a, we have a little bit of work to do. You have to put this in radian measure. So, you know, it's 4 pi over 180. But if you recognize that 240 is 4 pi over 3, you can use either or. It will work either way. So if you use 240 pi over 180, or if you use 4 pi over 3, because we're going to use a calculator, it will work. So you decide. So our arc length for this one is just going to be 13 times either 240 pi over 180 or 4 pi over 3. We are actually going to put 4 times 3.14 divided by 3 into our calculator. So you're going to do 13 times 4 times 3.14 divided by 3. And let's round it, since it's most common for our pi to be 2 decimal places. Let's go 2 decimal places for an arc length of 54.43, and it was in inches, so this would be in inches. So you do have to know the arc length formula. Let's talk about the area. The area formula is 1/2 r squared theta, same exact r and same exact theta as the above section. R is your radius, it's a length, and theta is in radian measure. So I'm going to focus on B since it's not ready to go. Now A, you would just do 1/2 times 15 squared times pi 3.14 divided by 3. But 225 is not in radian measure. But if you do 225 pi over 180, you can leave it just like that in this formula. You don't have to reduce it. But if you want to reduce it, you can. We know from our unit circle that that's 5 pi over 4. So you can use 5 pi over 4. It works just fine too. Excuse me. So our area is going to be 1/2 r squared, so it's 1.5 squared, times 5 pi over 4, or times 225 pi over 180. They'll both work just fine. 1/2 times 1.5 squared times 5 times 3.14 divided by 4. You can just throw all that into a calculator. We're going to round it, like they said, to the hundredths place, so 2 decimal places. Gets us 4.42. And this was feet, so that would be square feet. So just follow the instructions as far as rounding goes. Now, for now, if I skip a problem, you skip a problem. We're going to skip 6 for now, and then we're going to jump now to 7. So when you see a problem like this, do not overthink it. It is just a right triangle. It is a SOHCAHTOA problem. So based upon the angle they've shown us, my first suggestion to you, like always, label our opposite, label your hypotenuse, label your adjacent. So the first thing you should do is always label your sides. Now, it says, you'll notice, exact values. So anytime it says exact values, think unit circle. My unit circle would be the thing that would be helpful to me. But first, let's just set it up. To solve for y, since that's our opposite and we know our hypotenuse, that forces us to use the sine. I know that the sine of 60 degrees is opposite over hypotenuse. Now, if it wasn't a unit circle value, you would put this in your calculator at this point. You kind of can, but you kind of can't. You got to be careful. The sine of 60, we know from our unit circle, is square root of 3 over 2. And then you just cross multiply, cross by 26. So we get 13 radical 3 is the exact answer. Because you would get 26 divided by 2, which is the 13. The radical 3 is just going to hang out. Now, they also ask us to find x. At this point, you can use Pythagorean theorem. That works just fine. X squared plus y squared equals z squared or r squared. But you can also do a cosine. A cosine of 60 degrees is adjacent over hypotenuse. Now, using the same point on our unit circle, at 60, the cosine is 1/2. Cross multiply, 1/2 times 26 is 13. But if you did the Pythagorean theorem, you would also get 13.
Do we have to have radicals?
Yes, when it says exact values, you're going to want to have radicals in your problem. If it didn't say exact values, it might say round to the nearest blah, blah, blah. Then you can use a calculator. You could technically have used a calculator here, but if you don't recognize that the cosine was 1/2 and the sine was square root of 3 over 2, that square root of 3 might get lost for the thing. Now, what's great about it is if you put this one into the calculator and got 13, you can do the Pythagorean theorem for 13 and 26. It will give you 13 radical 3. So you can use Pythagorean theorem and a calculator, you know. Okay. You can do these problems multiple ways. For now, we're going to skip 8. Could you now move on to number 9? Number 9 says the point -7, -2 is on the terminal side of the angle in standard position. We're going to do number 9. Now, I've given myself a little bit of room somewhere. So I did give myself some room here. Okay. Sorry, let me erase and then we can show you how I got that.
Did you rewrite number 9?
I had copied and pasted it. Yeah, I had actually physically copied and pasted it. Sorry, I thought I erased everything, so I was ready for you, but I wasn't. Okay. So, we have done these in so many different ways, and we keep coming down to the same exact thing. For this problem, you are going to make your xy axis. You are going to the point -7, -2. You always connect the point to the origin and the x-axis. Let me say that again. You always connect the point to the origin and the x-axis. Let me say that again. You always connect the point to the origin and the x-axis. That has not changed in any iteration that we have done. The theta is always the angle closest to the origin. We're going to write, let's put in our -7 as our x value, so that would be our adjacent side, and our y value would be going down. So we have to use the Pythagorean theorem because our hypotenuse, which we'll call r, would be x squared. The sum of x squared plus y squared is r squared. So that's just going to be -7 squared plus -2 squared. Now 7 squared is 49. 2 squared is 4. 49 plus 4 is 53. And then we have to take the square root of this. Now, normally I would suggest to always put that plus or minus, but this is a case where it's always positive because our radius, remember, is the one that is just indicating a length and nothing more. Now, x or y might be positive or negative depending on the quadrant we've landed on, but r is always positive. Okay. So now let's remember what we know. Using SOHCAHTOA, or the fact that sine is y over r, or opposite over hypotenuse, we get negative 2 over radical 53. Cosine is negative 7 over radical 53. And tangent is y over x, or negative 2 over negative 7. Now, the test is multiple choice, so you could probably just show me up to there and then find the correct answer. But let me show you what the answer would look like. This would be negative 2 radical 53 over 53. This would be negative 7 radical 53 over 53. And this would just be positive 2 sevenths.
So all the questions up here are going to be multiple choice? Okay.
Now, it's said to find all 6 of our trig functions. We've only found the first 3. The other 3 we find using the reciprocals. So I would just write cosecant next to sine, secant next to cosine, cotangent next to tangent. So I've always kind of written in that order. It helps me, it helps you. I would continue to write it in that order. Flip over the one that is most convenient to flip. So I'm going to flip over this one. I'm going to get negative radical 53 over 2. I'm going to flip over this one, which is negative radical 53 over 7. I'm going to flip this one, which is 7 over 2. So expect one like that on the test for sure, okay? There will definitely be one like that on the test. So that's number 9. Okay, now let's go ahead. Let's go back up to where we were. Sorry about that, but you know. Now I'd like to talk about number 11. It says to evaluate the sine, cosine, and tangent of the following measurements without a calculator. So that's just indicating that it's a unit circle value somehow. 300 degrees is related to 60, but in the 4th quadrant. So that would be 1/2 negative square root of 3 over 2. So our sine and our cosine and our tangent would be found using that point. Remember, the sine is your y value. The cosine is your x value. The tangent, you're going to put your y over your x. Now let's practice doing that for a moment. We can do big C over little c. That's totally an option and works very well for this problem. Because big C and little c both contain a 2, you can cancel those out. We get negative 3 over 1 or negative radical 3. So that is 11A. For 11B, feel free at any time to convert that to degree measure. I tend to convert most things, whether I do it out loud or just in my head. I do tend to convert it first because I can visualize where 150 is. On the unit circle, 150 is in your 2nd quadrant. It would be negative square root of 3 over 2, but positive 1/2. So the sine of 150 is the y value, 1/2. The cosine of 150 is the x value, negative square root of 3 over 2. The tangent of 150 is the y value over the x value. So it'd be 1/2 over negative square root of 3 over 2, which was negative 1 over radical 3, or negative radical 3 over 3. So these are the main things you want to remember from your unit circle, that the sine is y, the cosine of it is x, and the tangent is y over x. Did you get one of those? I need it. Okay, so that's that. Now 12, they didn't ask for anything but the point on the unit circle, so let's just do those real quickly. 7 pi over 6, again, I like to convert. That's 210. So that's in the third quadrant. That's related to the 30. The pi over 6 is related to the 30. So that's going to be negative square root of 3 over 2. Negative 1/2. Eight pi over 3 is more than you want. But if we do 8 times 60, or 8 times 180 divided by 3 is 8 times 60, we get 480. If you get something higher than 360 or negative, just to relate it to 360, if you subtract 360 from that, we've actually landed at the 120 spot. So that's the point we use on the unit circle. Whatever is coterminal, wherever you land. I land at 120. The point at 120 is negative 1/2 positive square root of 3 over 2. 3 pi over 2 is 270. .270 on the unit circle is the point 0, negative 1. So there's 12. Okay, let's take a look now at 13. 13, the main things you want to think about is what you see here. Let's go over what we know. Now, I did cosine since that's the first graph we're going to do. Remember, the front value, our A value, the absolute value, that is an amplitude. It does flip if it's negative. The BX tells you about the period. For every single function except tangent and cotangent, you set BX equal to 2 pi to calculate the period. But for tangent, you set, and cotangent, set it equal to pi.
What's that symbol next to the
That says PER, I'm sorry. It doesn't look like anything good. Anyway, the phase shift, you're going to set the inside equal to 0. The vertical shift is the midline, and that's that number out there. Okay, so I would write that down. That's something that you will have to know for the test. Now, again, that works for everything. Watch the period. That's the only one that there's a difference for the tangent and cotangent. You set the BX equal to pi. Everybody else is 2 pi. Now we're going to graph quite a few of these. Well, as many as we can. We'll go as much as we can, but we are going to try to graph, before this is all done, we'll graph one of each. We'll graph a sine, a cosine, a tangent, a cotangent, secant, and a cosecant. You forgot that this stuff existed, didn't you?
Just a little bit.
Okay, so hopefully you have that written down. I have kind of cut and pasted it down here below. So it's the same thing. But the next thing you want to write down is this right here, okay? So remember, You should look first. This is a cosine. We're going to graph 1/5 cosine of x. And this is our original cosine. Now let's answer all the other questions about the cosine. So remember, our cosine goes from 0 to 2 pi. Just count by pi over 2's. We're going 0, pi over 2 pi, 3 pi over 2, and 2 pi. Our cosine goes 1, 0, -1, 0, and 1. So you have to know that. Just follow the unit circle, flip around it using your quadrantals every 90 degrees, and you got that. Okay. Now let's break apart what we know. So in this, we know that our amplitude is the absolute value of 1/5 or 1/5. So that's the A value right here. There is no change in the period. The period is just where does x equal 2 pi? Oh, 2 pi. The phase shift is where x equals 0, so there is none. The vertical shift is y equals 0. So this one, the only change to this function, it has an amplitude of 1/5. So to come up with a chart that matches this graph, it's just 1/5 times the old y's. So it's just 1/5 of that. So our x values are still going to go 0, pi over 2 pi, 3 pi over 2, and 2 pi. We haven't changed the x's. It says x right there. There's nothing to change. But our y's, we have to multiply all the old y's by 1/5. So 1/5 times 1, 1/5 times 0. 1/5 times -1, 1/5 times 0, 1/5 times 1. So now we have everything we need to know. We have a new chart for our new graph. We have the amplitude, the period, the phase shift, and the vertical shift for our graph. So now we are ready to actually graph it. So if you could make your graph paper for me, kind of match mine. So I'm counting by pi over 2's, by half of pi's, and I decided to just make my axis go up 1/5, down -1/5. So get your graph paper ready. And let's go ahead and draw it. At 0, I am up at 1/5. At pi over 2, I'm at 0. For a cosine, you always get a half of a bump to start with. And then do 2 more points. So we get at pi, we're at -1/5. At 3 pi over 2, we're at 0. And you'll get a full bump. Okay, so let me say that again. For a cosine, the first 2 points give you half a bump. The next 2 points finish a bump. And the last point is going to give you a half a bump. So you always get half, a whole, and a half when you do a cosine if you did it right. Now, let's continue. I want you to fill up the graph paper every time. So we're going to fill it up to the left, finish a bump, 2 more points, finish a bump. I only have room for that half a bump.
Is this going to be online or on paper?
It's going to be a Google form.
Oh, no.
It's not that bad. Did you say we could go like one side of the note card or the whole thing?
You may fill it out. The note card, if you're a CCP student, you may fill in front and back with whatever you want, but you cannot have the unit circle. If you are not a CCP student, you may write whatever you want. Okay, so that is
I'm not ready yet.
A. We're going to do the next graph as well. I think we do the next graph if you want to get it ready. Yes.
So,
Correct.
These questions, everything, like you just said, it's multi-choice, so would we be given graphs that we have to match with the function?
So I might give you an equation and say, what is the amplitude of the function? I might give you an equation and say, what is the period of the function?
Okay.
I might say, there are a few that aren't multiple choice, and I might say, here is the equation, graph it. I don't know. I don't know if everything is.
Are you gonna like post like a picture of it? And, like,
And then you'll take a picture of it, yeah. So there's lots of times where you'll end up taking a picture of the of what you're doing. So plan on, as you're going through the test, you will be taking pictures of your work. Okay, now could you please,
should we go back to one?
we're gonna do C. We are not gonna do B just yet, we're gonna do C. Whenever you're ready, we're gonna do C.
Who's connecting their AirPods?
Everybody got that? Okay, so now if you could look at C. C is a sine function. Y equals 2 sine of x minus pi over 2. I have the original sine values from our unit circle shown right there. I have my graph paper. If you want to get graph paper ready, we are going to use the graph paper you see there. Okay, so let's get started. When we do this one, we're going to go down and we're going to use the amplitude, the period, all that stuff. So the first thing I would note is our amplitude is the square root of 2, or 2. If you set your bx, your x term, only equal to 2 pi, that is your period. If we set the entire fraction equal to 0, that is going to be our phase shift. So to solve that for x, we have to add pi over 2 to 0, or we get pi over 2. Now remember, for our new graph, that is our starting value. So our phase shift is the first x value on our chart. Now our ending value, you're going to set that equal to 2 pi. So our starting value, you set that equal to 0, which also gives you a phase shift. For our ending value, you're going to set that equal to 2 pi. Well, if I add 1/2 to 2 wholes, which is 4 halves, plus 1/2 is 5 halves. So that's our ending value on our chart. Just start cutting it in half and cutting it in half again. Halfway in between 1/2 and 5 halves is 3 halves. Halfway between 1/2 and 3 halves is 2 halves, which is a whole. Halfway between 3 halves and 5 halves is 4 halves, which is 2 pi. So now we got our x's. The y's are easy. It's just 2 times the old y's, because there's nothing else on the outside of the function except the 2. If there was plus something on the outside, we would have to add that on, but there's nothing. There's just a 2. So multiply all these by 2. So 2 times 0, 2 times 1, 2 times 0, 2 times -1, 2 times 0. So now we have everything. We could say that our vertical shift is at 0. There's technically, even on the first problem, there was a midline at 0 that you could always put on the graph if that helps your brain. So now we are ready to go. So let's take and graph this function. So at pi over 2, we're at 0. At pi, we're at 2. At 3 halves, or 1.5 pies, or 3 pi over 2, we're there. Now, the first 3 points on a sine always gives you a bump. The first 3 points on a sine always gives you a bump. And then at 2 pi, we're down at -2. And the next 2 points should give you a second bump on a sine. So a sine is a little nicer to visualize because you get the first 3 points give you a bump. The last 2 points finish out a second bump. So then let's go down, back up. I didn't put that one at a good spot, but I went down a little too far. And then, back down. And down. Please, 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 always extend your graph on the fullest length of the graph paper. Please extend your graph to the left, to the right, because these graphs go on and on forever and ever and ever and ever. So that is a graph of a sine and a cosine. Okay, so now let me go back up to my graphs. Let's do G and H, a secant and a cosecant. I'm going to start with G, a secant, half of a secant. Secants are nice. They are related to our cosine, which goes 0 is at 1. Pi over 2 is at 0. Pi is at -1. 3 pi over 2, so this is just the cosine, is at 0. And 2 pi is at 1 again. So our secant we are just going to take the reciprocal of those. So that's going to be 0, pi over 2 pi, 3 pi over 2, and 2 pi. The reciprocal of those are 1 vertical asymptote, because it's undefined, -1 vertical asymptote, and 1. Now, for G, we only have the 1/2 on the outside of the function. So the 1/2 is only going to multiply all of those heights by 1/2. So for this one, the amplitude is 1/2. The period is still 2 pi. The vertical shift is nothing. The phase shift is nothing. The only change is our amplitude of 1/2. So our new graph goes 0, 1/2. Pi over 2 is a vertical asymptote. Pi is -1/2. 3 pi over 2 is a vertical asymptote. 2 pi is 1/2. But nothing else really has changed. So I've made some graph paper if you want to take a second and make your graph paper. I've just counting by pi over 2s are pretty common. And then I've gone up 1/2 and down 1/2. Now, what I like to do for secants and cosecants is even tangents and cotangents. Let's put our vertical asymptotes on. We have a vertical asymptote at pi over 2. We have another one at 3 pi over 2. So now we know the spacing, so I will put that same spacing on all my vertical asymptotes for the remainder of the graph. Now let's put on our halves and negative halves. That's a 1/2. That's a -1/2. So then continue the pattern. That's a 1/2. That's a negative. That's a 1/2, and so on. Every of our upper bumps, because we can't cross over the middle. You never cross over the midline. There's the midline. We never cross over a midline for a secant and a cosecant. So this one has to go up so it doesn't cross that line. This one has to go down. This one has to go up. This one has to go down. This one has to go up. So this is G. So we're just going to do one more. We're going to do H, and then you need to turn this in. Okay, so you immediately need to turn this in. Okay, so we're going to do H as soon as you're ready. We're going to do H, and then let's turn this in. Now, if you see that it is a cosecant, we want to write the sign. So the sign goes 0, 0. Pi over 2 is 1. Pi is 0. 3 pi over 2 is negative 1. 2 pi is 0. So that's your sign value. So that leads us to a cosecant, which would be 0, vertical asymptote. Pi over 2 is 1. Pi is a vertical asymptote. 3 pi over 2 is negative 1. 2 pi is a vertical asymptote. Now, this time we have something on the inside of our function. The amplitude is 1. The period, we have to do some work. Where does x over 4 equal 2 pi? Where does that inside equal 2 pi? That x value equal 2 pi. And then we get 8 pi. But x over 4 is 0 at 0. So our starting place is 0, and we have to end all the way at 8 pi. So halfway between 0 and 8 pi is 4 pi. And this is 2 pi. And this is 6 pi. So we have to make our graph paper count up to 8 pi. So if we make this 0, 1, 2, 3, 4, 5, 6, 7, 8 pi. But we can still just go up 1 and down 1 because there's no change in our amplitude. There's no change in our y value. There's nothing on the outside of our function to mess up our y value. So it's going to go vertical asymptote 1, vertical asymptote negative 1, vertical asymptote. So now we're ready to graph it. So I know we're getting close on time here. So we can open up this page and look at this tomorrow. But again, let's put our vertical asymptotes on. We have one at 0 and at 4 pi and at 8 pi. So I'm going to fill up my graph paper that I've created. Halfway in the middle, at 2 pi's, we are up at 1. And at 6 pi's, we're at negative 1. So that's going up. That's going down. So this one's a down. This one's an up. This one would be an up if you wanted to put that on there. So please turn in what you have done. I know it's not going to be done. We're not going to finish this whole thing. Tomorrow we'll continue and do a little bit more. I do have a link to a playlist that matches this problem by problem. So if you want to study what we've done so far, or if you want to study more than what we get done today to start getting ready, I will give you a post to that playlist so you have it. But you need to do trig. every night between now and your test on Friday. Don't wait until Thursday. This is a lot of material. Please study between now and your test on Friday. Okay? So there you go.